Bringing AI agents into an enterprise data platform often introduces a creeping complexity that quickly chokes your infrastructure. You start with a simple connection, and soon you're managing an overgrown mess of custom code. Every time your engineering team connects a new assistant, whether it's Claude, GitHub Copilot, or Cursor, they have to build the exact same plumbing from scratch. We're talking custom OAuth 2 flows, complex rate limiting, and manual token management, all before the AI actually does anything useful. Multiply that effort across 4 or 5 different AI tools running simultaneously, and that custom integration surface becomes brittle and nearly impossible to maintain. Your engineers end up spending their days managing API connections instead of building data pipelines. The root issue is that these AI tools and your enterprise infrastructure lack a shared language. Without a standardized way to communicate, your agents either get too much context or too little, leaving you with unreliable outputs against your production data. Microsoft Fabric is addressing this by adopting the Model Context Protocol, or MCP, as the new architectural standard for all AI interactions. Think of MCP as a universal USB connector for AI. It replaces a tangle of proprietary cables with a single standard that any compatible AI client can plug into instantly. This flowchart compares the old integration method to the new standard. On the left, you have that tangled, unmanageable web of custom API versioning and token nodes. On the right, that entire mess is replaced by the clean, single green line of the MCP standard. Fabric splits this protocol into 2 distinct architectural paths: Local MCP and Remote MCP. Deciding between local and remote is a choice about where your agent autonomy should reside. The path you select dictates your level of control and determines how your data teams will execute their daily workflows. Fabric Local MCP is an open-source server built to run on the edge, and it is generally available right now. Looking at this split-screen layout, the left pane shows the primary input. Developers install the protocol directly on their machines as a VS Code extension, connecting their local environment straight into the Fabric cloud on the right. For data engineers, this means desktop AI clients gain live context of Fabric APIs and OneLake schemas. By reading the live specifications directly, the agent pulls actual parameter names rather than guessing based on outdated training data. DevOps engineers gain a different advantage. The Local MCP can wrap the Fabric CLI into tools that the AI can use, allowing your CI/CD pipelines to execute scheduled data operations entirely automatically. That automation is also where the primary trade-off lies. Removing the human in the loop means you lose manual oversight. If your deployment scripts aren't rigorously tested, the Local MCP can execute automated errors that cascade rapidly through your system. You trade cloud-wide ubiquity for high-velocity, localized code generation and granular control at the edge. On the other side is Fabric Remote MCP, which is currently in preview. This is a cloud-hosted architecture with no local setup required. You set this up by pointing team-wide autonomous agents, like Copilot Studio, directly at the cloud-hosted MCP server. For platform admins, this enables agents to autonomously provision workspaces, adjust permissions, and organize platform resources on behalf of your team, all without a human opening the Fabric portal. The trade-off here is twofold. First, because it's in preview, you may encounter feature instability. Second, it lacks the granular, code-level insight that developers get with the local version. You trade away fine-tuned developer control to gain team-wide autonomous management housed entirely in the cloud. Handing an AI autonomous access to your data platform usually triggers alarm bells. IT teams need to know if this introduces shadow permissions or creates new attack vectors. The reality is that both local and remote MCP route every single operation directly through Fabric's existing role-based access control. An AI request must pass through a security checkpoint shaped exactly like the user's permission profile. The agent can only touch what you can touch. But agents inherit your risks. If a user has overly broad permissions, the AI inherits that vulnerability, amplifying accidental exposure. MCP guarantees there are no shadow permissions and no new access roles to provision. However, it offers no safety net if your existing security hygiene is already poor. Your decision between local and remote MCP depends on whether your daily focus is building the data infrastructure or managing it. Looking at this decision tree, we start with your primary goal. Do you write code and deploy pipelines, or manage the platform and run autonomous workflows? If you are a data engineer or DevOps professional, follow the left path. Choose Local MCP if your priority is feeding accurate API specs to your coding assistant and scheduling unattended CI/CD deployments today. If you are a platform admin or a data team lead, your tasks pull you down the right path. Choose Remote MCP if you want to offload repetitive workspace provisioning and resource management to an autonomous agent running in Copilot Studio. Regardless of the path, the immediate action item is the same. Data teams need to audit their systems and begin deprecating the brittle, custom-built AI integration layers they currently rely on. Adopting MCP establishes the prerequisite architecture for any team planning to run agents against enterprise data. Standardizing on this protocol is the only way to ensure your AI tools remain secure and manageable as you scale.